Really nice to be here. It's my first time in Nantes. I'm looking forward to have some time tomorrow to see the city a bit. I have an English and a German version of this talk. There's no French version, unfortunately. I'm learning French right now, and I'm sure my French teacher would be very proud of me if I could give the talk in French, but I don't think that's going to be possible before like DevFest 2025 or so. But don't worry, I'm not going to give the German version. I'm going to give the English version, of course. And I wanted to start this by looking a bit at how web engineering, web development has evolved like over the last years, because things have changed a lot, and I've been working in this industry for 20 years almost. I just calculated that before the talk and was a bit shocked. And things were really different back then than like they are now, they are today. So in the past, websites sometimes looked like this, right? Pretty ugly, also no functionality in any sense on the site, but relatively simple, right? This is all just good old HTML, no scripts. So you could probably argue whether it's good old HTML or just old HTML, but it's relatively simple, no complexity. Also, it's just like stuff that's sent over the wire, and the browser just renders it using the HTML semantics. Today's websites are pretty different. Like they often look like this, right? Like we're now building actual applications that happen to run in the browser. They're much more powerful, but also they're much more complex, of course, right? Instead of just like presenting some static content, we're actually making functionality that is sometimes pretty advanced available to the user. So that leads to a lot of additional complexity, of course, and sometimes we might think that things are overly complex, right? And that leads people to say things like this. This is obviously an exaggeration, but I think there's some truth to it, and you get the idea, right? Like we are moving further and further away from the foundation of the web, which is really just like sending HTML from the server to the browser, and then the browser rendering that. We're doing everything in client-side JavaScript now. Even CSS in JavaScript is a thing now. And with all that, there comes a lot of additional weight and additional complexity that wasn't there only a few years ago. And that additional weight leads to a situation where applications are relatively slow to start up in many cases, because we're just shipping so much stuff into the browser that is all needed in order for the application to run. And that's in particular a problem on mobile devices, of course. Sometimes you might think that's not really a problem here in Western Europe, but it is actually as well, like if you exceeded your data limit in your data plan or so, or if you're in a tunnel or like in a remote location or so, you might sometimes browse the internet with like edge speed. So like big websites that ship a lot of code are actually a problem for you as well then. And of course, there's another thing. If everything is implemented in client-side JavaScript, if that JavaScript for some reason fails to run, there's just nothing, right? Because as everything runs client-side, if the code fails to load or it fails to execute because like you have a browser that doesn't support a particular thing that's used in the application, there's just nothing left, and you just look at a blank page. So in this talk, I want to look at different approaches for building websites, and then look at how we can leverage them for progressive enhancement, basically going back to a pretty old idea that was popular like a few years ago already, or maybe 1 or 2 decades even already. My name is Otte-Witte. I'm Marco W on the internet. I'm the founding director of SimLabs. We're a web consultancy from Munich. We work for clients all over the world, really also for some clients in France right now. And we help those clients by providing our workforce and also our expertise to make their in-house teams, or enable their in-house teams to move further and faster with confidence. But back to the topic. So first of all, I want to look at what SSR, SPAs, and PWAs even are, like what these acronyms stand for and how those work. And we'll do that using an example application. And that application is supposed to give people easy access to air quality data, right? Like, it's an important topic, and we're assuming we want to help raise awareness and make air quality data available to people, in particular on mobile devices. So if you would build an application like that, you would probably think of something like this, where the start page is just a search form, where you can search either for search term, right? You just put in Nantes, or you could search for measurement locations depending on your current location that the application would then just get from the phone. So once you search for a particular location, you would probably get a list of results, like a list of available measurement locations that the system has data for, and then you would select one and go to the results screen and see the actual data for that location, hopefully good data. So first of all, let's look at how we would build that with SSR, like the classic approach for building websites, where you just render everything on the server, and then you just ship the complete HTML document to the browser. So for that example app, and here we have the server on the right side, that would look something like this. The browser would send the request for loading the website, loading the app, and then the server just responds with that HTML document, right? Which is immediately usable, of course. In performance jargon, you always talk about time to first paint and time to interactive. Time to first paint is basically the time when the user first has anything from the server that it can paint on the screen, and time to interactive is the point in time when that UI that was painted on the screen actually gets interactive and the user can start interacting with that, right? So here basically both times are when the browser receives that initial HTML document, right? Like as soon as it has that, the browser can start painting that on the screen, and the user can also immediately start interacting with that. Then the user would probably enter a search term and submit the search form, which results in another request. The full page reloads, the server responds with the result for that specific search term, and then you have another full reload where the user selects one of these locations and the server responds with the HTML document for that particular URL. The characteristics of this approach are, oops, wrong direction, we have to go through it again. The characteristics of the approach are that the document is immediately visually complete as it is received from the server, and it is always also immediately functional, right? As soon as that HTML document is received, you can see it, you can start using it. But subsequent page transitions always require full server-side round trips. There's basically no difference in loading the initial page and any of the following pages. All pages are independent of each other, basically. So that is the classic approach for building websites. The first iteration step, on top of that, there was sort of a new thing, maybe 10 years ago or a bit shorter, was then single page apps. And the idea of single page apps is that you ship an essentially empty document to the browser that only has some script tags, and then once these scripts referenced through script tags are loaded, the application starts, and from then on runs in the browser without any additional full reloads. So for the example of that air quality data app, that would look something like this. You have the initial request again for loading the website. The server responds with that empty document that only has script tags. The browser then loads those scripts, and once the scripts are received and passed and executed and so on, the application starts up in the browser. So you see already that time to first paint and time to interactive are significantly later than with a classic server-side rendering approach, because after you have received like that initial HTML document, the browser still has to go get the JavaScript, and only once it has received that can it actually start up the application and the user gets to see anything. The next step then is that the user enters a search term again, and then instead of reloading the full page with single page apps, you would make a fetch request, and while that is loading, you would show a loading state in the application, so the user has like a better experience than with the previous solution where it just reloaded the full page, right? So you have more like application-like feeling, and that is really something that most of us are used to right now. And then once that request completes and the client received the response from the API, you would just leave the loading state, render like all the data in the browser, and then like that step's complete. The next step is then that the user clicks on one of those locations because they want to see the data for that particular location, and you have the same thing again. On the client, you go into a loading state for that new results route while you load the data asynchronously, and once the data comes back, you leave the loading state and render that page on the client. The characteristics of this approach are that the initial document that you get from the server is essentially useless because it's just an empty document with only script tags until the JavaScript loads and the application starts and runs completely in the browser from then on. The good thing is that subsequent page transitions are client-side only and thus fast. Like you're basically going immediately from that search form page to the page where or to the state where you show the loading state, right? Like there's no delay or so. Of course, you still have the loading state because you need to load the data lazily, but still the user experience is a bit better, although the performance is similar maybe because you have to get the data in either way, either case. And of course, a significant difference is that this approach requires JavaScript to work at all. This might sound like not a big problem, but depending on JavaScript is a problem in certain situations. So for example, for SEO, you still pay a penalty when your page requires JavaScript to render any UI at all. The Google bot will actually go and pass that and index that, but it's still like you pay a significant penalty. Also, there's other clients on the web like these little bots that Twitter and Facebook use to get like your Twitter card or the Facebook link preview where it inserts like a snapshot of your page's UI. Those bots do not run JavaScript and thus would not like be able to render a snapshot of your page. But there's another reason why depending on JavaScript is a problem potentially, and that affects all of your users in certain situations, because JavaScript is relatively slow, right? Like JavaScript bundles, like application bundles tend to be relatively big, as we saw previously. You can split the bundles and like load the code more efficiently, but still there's like a substantial amount of stuff that you need to ship over the wire. And then the second thing is that JavaScript is not just some blob that the browser can just receive and then like use immediately, but you're shipping code. And this is a screenshot from the Google Web Fundamentals guide where it compares the performance characteristics of 170 kilobyte JavaScript code and 170 kilobyte of JPEG. You see that the time for the network transmission is essentially the same for both cases, because it doesn't really depend on what you load. Like loading 170 kilobytes over the network always takes the same time regardless of what's encoded in those 170 kilobyte. But then you see on the right-hand side that everything that comes after the resource has been loaded is essentially immediate, right? Like it's like 0.0 something seconds to decode the image, and then 0.0 something to rasterize and paint the image. So basically, you could say once the JPEG is received, it displays immediately. It's pretty different for JavaScript. Like you see that after the resource has finished downloading, the browser needs to spend 2 seconds for parsing and compiling it, and then another 1.5 seconds for actually running the script. So you're spending the same amount of time that you spend for loading the resource for actually using it, processing it, right? So in the example of those 170 kilobyte JavaScript bytes, the result of that JavaScript only becomes active after 7 seconds versus the 3.5 something seconds of the JPEG code. So there's a huge overhead in all of the JavaScript that you ship to the browser. So that is something that you have to keep in mind. That it's not only network transmission time, but also everything that comes after that when you're using JavaScript. And we'll see whether it gets relevant later on in the talk. So we saw the classic approach for building web apps, which is server-side rendering. Then we saw kind of the first iteration step, which was single page app, and then the second iteration step on top of that is progressive web apps, which are sort of the hot topic right now. What progressive web apps are, they're usually single page apps plus service workers for better caching and offline functionality. And they're supposed to have like an app-like experience where you would install a progressive web app on your home screen, and then it would basically be indistinguishable from any native apps you have installed on your phone as well. Like they would run the same way. They would have like a similar user experience, and you're not supposed to realize that you're not actually running a native app, but actually a web app that has been installed to your home screen. We'll do a quick recap on service workers. I'm sure most of you are familiar with service workers, and we're only focusing on 2 main things here because everything else is not relevant in this context. Here we have the browser on the left, the server on the right. And we are assuming that the service worker has been installed already and is now like some piece of JavaScript code that runs locally in your browser. We're not going through the installation process as such here because it's not relevant for this. So assuming the browser on the left has a service worker for that domain installed already, what could potentially happen then is that the browser makes a request for something and the service worker intercepts that request and just serves the response from its own cache, right? So instead of actually requesting the resource from the remote server, you're just serving it locally from the service worker, which is obviously several factors faster than actually getting something from the remote server. So this is how you use service workers for improved caching. There's a second relevant use case here where the browser makes a request for something again. The service worker intercepts that request, and it would actually try and get the resource from the server in this case, but that might fail because like maybe the server is broken or maybe the device that the service worker is running on is offline. So in that case, you would sort of fall back to serving the resource from the service worker's cache. And that is basically how you build offline support for web application. The first thing where you just always serve the resource from the service worker's cache is when you can be sure the resource is not stale in the cache. And the second case is where you just use the cache as a fallback if the actual request doesn't work, and that's what you use for offline support. Service workers are supported in most browsers now, not Internet Explorer, of course, but that becomes like, less and less relevant. And what you usually do when you write a progressive web app is that you use the app shell model. And the idea behind the app shell model is that you serve the application's main UI shell from the service worker. So the user gets some visual impression of the app immediately because the resource is like served locally from the service worker, and then you fill in the content and functionality dynamically as the application starts up, and basically from then on it's just a regular single page app. Example for that is looks like this, server on the right again, and here we're assuming that the service worker has not been installed yet, right? So basically the first request to that domain. The browser would make the request here, then the server would serve the app shell. Like I said, app shell is really just a very like generic or a very rough representation of what the application will eventually look like. So when you look at the performance metrics again here, that you could argue that time to first paint is relatively early, right? Because we immediately have something that we can paint on the screen when we receive the first response from the server. But that thing that is being painted on the screen is essentially useless, right? It's very similar to a blank page. It makes it feel a bit faster maybe because you get a rough impression of what the thing will eventually look like, but it's not like meaningful to the user really. What happens then is that the browser makes the request for the JavaScript bundle, like with a regular single page app, and then once it has received that, it would actually use that script and start up the application. And here's the first time where the browser actually paints something that is meaningful to the user, which is also the reason why there's, besides time to first paint, there's also a second measurement, which is called time to first meaningful paint, and that is exactly this time here, right? Because this is the first time that there's some like meaningful stuff being painted on the screen instead of just some like very generic thing. Also, this point in time here, of course, is also time to interactive, because this is when the user can actually start using the application. And this is also when the service worker installs in the browser. So now we have the application running on the browser. Service worker has been installed. So let us assume we're now refreshing the page. So the browser will make another request, like for the same resource, but this time the service worker will intercept that request, serve the app shell, and then the browser would request the resource, would request the JavaScript bundle. Again, service worker might intercept that as well if the resource in the service worker cache is still fresh and the application starts, right? So you get the app shell immediately from the service workers, so you have something to show to the user immediately, and potentially you get the other resources from the service worker cache as well, if they are still fresh. So the characteristics of the approach are that some visual content is immediately available, although, as we said, the app shell has no real value for the user. It's mostly improving the perceived load time, because instead of just looking at a blank page, you have some app shell to look at that that at least gives you an impression what the app will eventually look like. The application works offline as well, which is a pretty good benefit, of course, because you can just serve stuff from the service worker if the device is offline. But still, of course, you require JavaScript to make this work at all, right? Because if there's no JavaScript, there's no single page app running in the client, there's no service worker, because service workers are JavaScript as well, of course. So the whole thing falls down if you don't have JavaScript. So now we have seen 3 different approaches, and it seems you just choose one that serves your particular use case best. But I think in reality you can choose all and combine them all. And the idea for that approach of combining them all would be that you just write your regular single page app, but instead of only running it in the browser, you're also running it on the server side. So you can deliver a meaningful initial document versus just an app shell or just an empty page, while keeping all of the benefits of the single page app, because you would still start that up in the browser later on in the process, sort of. And then in addition to that, you would combine that with service workers for better caching and offline support. I have a little schematic here for showing that. So here we have the client on the left again, server on the right, and on the bottom right there's the data server that the single page app loads data from. So now we take our single page app and we move it to the server, which might be like an Express server. So, you're running Node.js on that server. And what happens then is that the client makes the request for loading the website, starting up the web application. The server runs the application on the server side, potentially loads data from the API, and renders what the single page app renders into a string, which then is the response that it serves to the browser. The browser has an HTML document that it can render immediately, and that document, of course, still has the script text, so the browser would still load the JavaScript, of course, and that's when sort of the application moves from the server side onto the client, where it just runs then. So depending on your framework, you would, at this point, you would either render everything again and replace the whole DOM in the browser, or you would attach the application instance that you're starting up in the browser to the pre-existing DOM that was received from the server side as the response for the initial request. Depends on the framework you're using. Both things basically work the same way. Either, even if you're just re-rendering everything, that doesn't really have a visual impact for the user, because the same application being rendered on the server side and being rendered on the client side obviously would produce the same output, so there's no visual difference for the user, even if the application re-renders the complete DOM. And from this point on, it's really just a normal single page app that runs in the browser. It talks to the API server directly, for example, on subsequent route changes. And then you would just add service workers on top to improve caching and add offline functionality. So the characteristics of the approach are that you're running the same single page app in the browser and on the server. You don't need to write a second app. You're just reusing your existing single page app. And there's also no conceptual difference between those two instances of the same app. Also, in the view of the data server, there's really no difference where the request comes from, right? Like whether the request comes from the browser or whether the request comes from the node server that runs your single page app for pre-rendering responses. So in theory, you could run that pre-render server even outside of your firewall, right? Because in terms of security, it's just another client, and the only difference to everybody's browser running your single page app is that the JavaScript environment in that particular case happens to be a node server and not like Chrome or Safari or whatever. And the major benefit, of course, is that you're able to ship a valuable initial response, right? Because you're rendering server-side, make a snapshot, and then just use that string as the response for the request for the initial document. There's a few things that you need to be aware of. First of all, obviously, there's no browser APIs in Node.js. So for example, if you're using things like local storage or so, those obviously would not work in Node, and you would have to check like which environment you're running in and maybe do something or not do something. And the same thing, of course, is true for any dependencies you're using. So you would have to use isomorphic dependencies, and isomorphic in that case basically just means that it's JavaScript that's capable of running in the browser as well as inside of a Node server. So we look at a more concrete example for the approach as well, and we'll be using an application that we actually wrote. So this is a progressive web app that we wrote, and that basically implements the exact same feature set of that theoretical application that we used in previous example. So we call it Breathe. It's like a play of word between breathe and breeze, like that light wind. It's a technology showcase that we built. Basically, it's fully open source, and it, like I said, it implements the exact same feature set of the previous application with that approach that I just introduced. So here's a quick video that I recorded in the iOS simulator that shows you how the app works. So you have that start page here with a search form. You can search for a location. We have the loading state. You can select a location. We have another loading state for that new route then, and you see the data there. And then I think here we click at the we click on the logo at the top, which is basically just a link to the home page. We have recent locations. Those are stored client-side. And then we have a link for finding measurements locations that are close to you. So let's look at let's have a slightly more detailed look about how the startup process and sort of the flow through the application works for this particular application with that pre-rendering approach that I showed. So now here we have the pre-rendering server on the right. The browser would again make the request for the initial document. The server then runs the application, renders everything that the application renders into a string and responds with that, right? So here we have like a really early time to first meaningful paint. It's basically the same as for the classic server-side rendering approach, and way better than single page apps or progressive web apps, right? Because this, as soon as the browser receives something, we have something to render already. Then the browser, of course, goes ahead, loads the JavaScript bundle, and then as soon as that is there, it starts up the application in the browser, but there's no, that is not really noticeable to the user, because you're just, like I said, either just rendering the same thing again and replace the DOM, or you're just attaching the application instance to that pre-existing DOM. And this is when time to interactive happens. It's only after the JavaScript has loaded as before. And from then on, it's really just a normal single page app. So the user would put in a search term, the application would load the data, going through the loading state, leave the loading state once the data is there. So as soon as the user selects something, go to the next loading state, and so on. So yeah, from then on, it's really just a normal single page app. And server-side pre-rendering, of course, is especially usable when the document that the browser is requesting actually contains data, right? Where it's really valuable if you can see that information or that content or the data earlier rather than later, right? So what if the user started the application not on the search form, but on the results route for a particular location, right? Obviously, pre-rendering for that works as well. The browser, the server in that case would just load the data from the data API, pre-render the response for that data, and ship that to the browser. So you have like immediate access to the data that you care about, without necessarily having loaded the JavaScript yet. So this is nice, but this is not all what we did, and now we're coming back to the subtitle, which is progressive enhancement. Progressive enhancement means that you're only using JavaScript and other things potentially, but maybe JavaScript, to enhance the document that was received from the server, but you don't necessarily require JavaScript to have anything at all, which you normally do with single page apps. So the question is whether we can have like a baseline functionality for this application without any JavaScript having loaded at all. So basically, whether we can time to interactive the same as time to first meaningful paint, right? So the goal would be that the pre-rendered response that we receive from the server is not only like visually complete, but also at least to some extent also usable by the user. Of course, that might sound a bit strange when we're talking about single page apps, because they are written in JavaScript and supposed to run in the browser, but it becomes possible when we run those single page apps on the server side as well. A very simple example first, maybe. So if we assume that the application is started on that results route here again, and then before the JavaScript has even loaded, the user clicks on the link on the home. The user clicks on the link on the logo at the top. That is basically a link back to the home page. That is, of course, functional without JavaScript. Like if JavaScript had been loaded and the single page app would be running in the browser, you would basically intercept that request and make that round change on the client side only. But without JavaScript, this is just a regular link. So we just have another request to that pre-rendering server. The pre-rendering server would like run the application for that route, capture what the application renders in a string, and respond with that to the browser, right? So this is pretty straightforward. But what about the search functionality? Here I have to say that the previous example was a bit simplified, and the first iteration of the application that we wrote actually looked like this. So the browser would make the request to load the application, and the pre-rendering server would respond with that pre-rendered response. But here you see that we have a loading state that is over the search format, because the search is written in JavaScript, right? So we handle the submission of the search form in JavaScript, and it is not functional until the JavaScript has loaded and the application started up in the browser, at which point we remove this loading state, right? So here we sort of incrementally start up the application, right? Like we start with a limited set of things that the user can use, like links and so on, but switch off everything that absolutely requires JavaScript to be working at all. So this is nice, but we went a step further, and we wanted to make our JavaScript application functional without JavaScript. So basically, the goal was to make that enhancement smaller, right? So we wanted to go from a basic search functionality to an improved search functionality, instead of going from no search to a good search, right? So, like I said, the search form obviously is handled in JavaScript and would just be a fetch request when the application has started. But what can we do if the application has not loaded yet? So again, the browser would load that search form. Here you see we have removed the loading state, and then the user would enter a search term, and instead of like waiting for the JavaScript to be loaded or so, we just submit that form as a regular, like plain old HTML form, right? And then the server receives that request. It builds up an application state from that query param, runs the application on the server side for that state, and responds with whatever the application renders for that particular state, right? And how does that work? It's relatively straightforward. This is what the template looks like for the search form. So we use a regular form, and we handle the submit event with a JavaScript function, right? Which would actually prevent the actual submission of the form that the browser would normally do. But when we render this on the server side, we just leave out the onSubmit handler, right? So that what the browser receives is just a plain HTML form that is submitted via GET, and then when the application starts up in the browser and the application re-renders the DOM or attaches itself to that pre-existing DOM, it just adds in that onSubmit handler again, right? So here we have a baseline functionality for the search, which is just submitting a regular form, and as soon as the application starts up, we improve that experience by handling that all in JavaScript, which allows us to go to a loading state, make a fetch request at the same time, and so on, give the user a better experience, which is exactly what progressive enhancement means. The last thing that we want to make sure works is the location-based search. So here we load the application again, and then if the user clicks on that show nearby locations link without the JavaScript application running in the browser, we just make that a normal link, right? And we define a special URL for that the server can recognize, and then just infer the user's location by their IP, right? And then it can just render, or it can just like respond with whatever the application renders for that particular location that the server inferred from the user's IP, and respond with that, right? So here again we have a baseline functionality that works without the application running in the browser, and an improved functionality after it started up, because in that case we use the geolocation API, have loading state again, and so on. How do we do that? It's essentially the same approach again. We have a regular link with an on-click handler. The search by location function would basically like go to the loading state, get the location through the geolocation API, and so on. But everything that we render when we pre-render on the server side is just that regular link. We just leave out the on-click handler, and then when the application starts up in the browser, it just adds the event handler to that DOM element again. So now we have a single page app that does not require JavaScript in the client, degrades gracefully if JavaScript in the client is for some reason not available. Or in other words, progressively enhances the pre-rendered document, right? So the baseline functionality does not become available through JavaScript. It gets like improved once JavaScript is running in the browser, and JavaScript is not actually necessary to have anything as well. This is not only relevant, of course, when JavaScript is disabled in the browser or for some reason fails to start, but being able to, or having some level of functionality available for the user without JavaScript also means that you have some level of functionality available for the user before JavaScript, right? And now we get back to that chart that we looked at previously. JavaScript is relatively slow, right? So with server-side pre-rendering, we get time to first meaningful paint actually 7 seconds faster, right? Because the browser is able to render something without having loaded any of the JavaScript at all, although we are actually running a single page app. And then with progressive enhancement, we get time to interactive 7 seconds faster as well, because we don't necessarily need JavaScript in order to make the functionality that the application provides available, but we're only improving that functionality, but there's a baseline functionality that the user can start using 7 seconds earlier in this case. This is not just nicer for the user, but often there's real value in that, right? Because improved performance might result in improved conversions or so on. Like all sorts of metrics that are relevant for your business probably get improved when you improve the startup performance of your application. So essentially the main point of the talk, and there's little time left, but that should work out pretty well. The main point of the talk is that SSRs, SPAs, and PWAs, or SSR, SPAs, and PWAs are not mutually exclusive things, but actually complementary technologies. So you would use server-side rendering to deliver content, right? Like the application's main content, as well as a baseline functionality for what the app does. Then on top of that, once the single page app started up in the browser, you improve that UI and user experience, and you maybe make the functionality like more advanced, or sometimes you might not be able to deliver a baseline version of some functionality in the pre-rendered response, so you would only make that available then once the single page app starts. And then you add progressive web apps to support offline mode for the application, make the application installable on the user's home screen and so on. So, like I said, the Breathe app is open source. It's available on GitHub. I encourage you to check it out and contribute maybe. The server part that is written in Elixir is on GitHub as well. It was built with Glimmer.js. Glimmer is a component library built on top of the Glimmer virtual machine, which is Ember's rendering layer, but this just details here. The server-side pre-rendering part is just an Express server that runs the Glimmer.js app inside of an Express server, and then depending on the accept path and query params of the incoming request, it would just build up an application state, inject that into the Glimmer app, run it, capture what that renders in a string, and respond with that string. They are ready-to-use server-side rendering solutions for most frameworks. So for Ember, for example, there's Fastboot that's available as a plugin. There's solutions available for other major frameworks as well, and I can only encourage you to use them if you care about startup performance, and also think about how you can like use progressive enhancement to make that pre-rendered response also functional. For many use cases, that might not be as hard as you think, and that's it. Thank you.